Hello everyone, welcome back to the channel, and in this video we are going to build something modern crypto market application using Jetpack Compose. So basically this is an app which fetches real-time cryptocurrency data from the internet and display it in a clean and professional UI. Supports infinite scrolling pagination, pull to refresh, and even draws a custom charts using Canvas. This tutorial is designed for beginners, but it is also demonstrate real-world Android development concepts, and basically these type of architecture can be used in production apps and your interviews too. So let's begin, and make sure you like and subscribe the channel. So before starting, let us understand what we are building. So basically, let's understand what this app does. So this app displays the cryptocurrencies as in like a Bitcoin, Ethereum, and many others. Like this is the app which we are gonna build today, and you can see all the cryptocurrencies over here. And basically, what are the data which we are going to see on our app? Basically, first of all, it's coin name and symbol. You can see here Bitcoin and BTC. Similarly for Ethereum and ETH, and then current market price. This is in rupees, and then you can also see how the market changes in last 24 hours. So you can see that the Bitcoin goes like -1 or almost 2% down in last 24 hours, and a small price chart which shows the trend. Okay, and the other main features of the app is like as you scroll, uh, the list don't end. This is an infinite scroll, and then we are like basically this behavior is called infinite scrolling, and it is commonly used in real finance app and trading app. So let's start. So let's deep dive into the product, or what we say, project structure overview. So before writing code, it is important to understand the structure of the app. The app is divided into four main layers. First layer is data layer. So this, which what you are seeing, is a data layer. So data layer is a layer which describes how the API data looks like. So basically what API returns, same thing we are like gonna like make a class, data class of the things that API returns as a data class. And then we have retrofit. So basically retrofit is a package which we are using to get the data from the API or hit the API from the servers. So this is a part which is a API interface. This is the second part of our code. And then we have ViewModel, which manages data, state, and business logic. So basically this is the whole part from the you can see that data models and everything, every functions here. And after that, finally we have our Jetpack Compose UI, which displays everything on the screen. The data flow is simple and clean. Data flows from API to view model, and then from the view model to UI. The UI never talks directly to the internet. So let's start with the data models. So basically, data models are the simple Kotlin classes which represent the JSON written by the API, such as like each cryptocurrency contains information as an ID, a name, a symbol, a image URL, a current price, a market rank, and a price percentage over like 24 hours. And then uh, the API also provide the list of the prices for 7 days, and we store this list separately in a Sparkline data class, which we later use to draw this chart. You see here, na? It's a chart which we are later using it to draw the chart. And these data models allows retrofit to automatically converts the JSON into the Kotlin objects. So what are we doing in data class? We are mapping all the API's return values into the data class, and we also made one list of Spark line items to make a chart. And then let's move to retrofit, a network layer. So let's now talk about retrofit. Retrofit is a networking library used to make API calls in Android. Instead of manually handling HTTP requests and JSON parsing, Retrofit allow us to describe our API using single interface. Inside the interface, we defined a function that sends a get request to fetch cryptocurrency market data. We pass parameters such as currency type, sorting order, page number, whether the Sparkline data is required. This function uses suspend. You can see this suspend. So basically suspend, which is which runs asynchronously using Kotlin coroutines. Retrofit automatically converts this API response into list of our coin data models. So you can see here, these whole things are converted into coin data models. And whether uh, this keeps our networking code clean and reliable and safe. So this is what our API call of retrofit looks like. Here we are constructing basically the whole URL. So this is the get method, and this will get attached after this API using all these parameters. And then it will be, the data of this will be coming into CoinDTO, and then we are creating the base URL. After that, the raw data from API here is converted into like Kotlin objects, and then the build function is used to say ki now the thing is built, and after that it not be things not will be changes. And then from the create class we are creating the Kotlin API as a class, so all the things will be gone into the Kotlin API. And then we have view model, the brain of our app. So basically the view model is responsible for handling the holding the data and managing the business logic. It stores the list of points, loading state. You can see the list of points, loading state, refreshing state, and error message. So all states are observable, which means the UI automatically updates the data change. So view model uses view model scope. So basically you can see here view model uses the view model scope to launch the coroutine safely. This ensures the network calls are cancelled when their view model is destroyed, preventing memory leaks. So basically what we are doing, we are using view model scope, which is linked to the part of coroutines. What it does, it like destroys the thread where the uh, call is happening to the internet when the view model is destroyed. After that, what we are doing, initial data load in the init thing. When the view model is created, it initially loads the first page of data. This is done inside initialization walk. As soon as the app started, the first branch of the cryptocurrency data is fetched and displayed on the screen. So this is what init state is. So init state calls the first function, which is load next function, and init is a function which executes one time, and it always executes when the page is when we went to the page. And there's the topic of pagination comes. So pagination means loading the data in chunks instead of loading everything at once. So like you can see there, this is already loaded. That's why, see, like you can see the pagination thing. So the view model keeps track of the current page with a number, and like whether more data can be loaded. In the UI, we can monitor scroll position of the list. When the user scroll like closer to the bottom of the list, the next page data automatically requests from the API. The new data is appended on the existing list, creating a smooth finite scrolling experience. This approach improves the performance and reduces the unnecessary network uses. So basically the whole thing does the pagination and other thing. What here we are like basically monitoring. If the user comes to the end of the list, then it says to the API, yeah, you can load the next API, which saves time and also basically make our app less dependent on the net. And then we have a feature known as pull to refresh. So I'll show you in the app. If you go here, go to the top. I think we came very down. So yeah, this feature is pull to refresh. So this got refreshed. And so basically, when the user pulls down the on the list, the refresh function is triggered. This is the refresh function. What it does when the user pulls out, the page counter is reset. You can see here the page counter is resetted, and old data is cleared and fresh data is fetched from the API. This gives similar like user-friendly way to refresh the content. So this is what uh, completes our third part. And now let's go to the UI component part. So let's move to one of the most important part of the app. We use Canvas to draw the custom chart directly. So the chart that we are using is Canvas, and here we are drawing the chart. First, we calculate the minimum and maximum value of the price. You can see here. And then we normalize the price to fit within the available screen price. Using the path, we draw a smooth line connecting all the price point. To enhance visual quality, we also draw a gradient filled area within the line. The color changes dynamically, green for positive price movement and red for the negative movement. This gave a quick visual understanding of market trends. And then after creating a chart, we have a like our Compose UI. So what does Compose does? It like renders the entire interface using Jetpack Compose. We use a scaffold here. You can see the scaffold here. So scaffold to provide a structured layout with the top bar and content chart. The list of cryptocurrencies displayed during lazy columns. So basically, lazy columns like renders the things which is in the screen. For example, if you're seeing all these things on the screen, lazy columns only renders that. It won't render other things. So things or the tiles in the screen is rendered by a lazy column, and other thing which are not in the screen are not rendered. So which save memory and many increase the optimization and performance of the app. So each coin is like shown inside a cart. So I can show you the icon items, and with the layout created, basically the layout is created using rows, columns, and box. Images load asynchronously and text add using Material 3 typography. The app uses a modern dark theme. Compose automatically updates the UI whether the view model state changes. There is no XML and no recycle view updaters and no manual UI updates. And then we have loading and error states. So basically, if anytime the error will come or any other thing will come, while data is loading, a progress indicator is displayed. So if I rebuild the app, I'll show you. So you can see the progress indicator is like loading, and the error, when the error or no data comes, it will show an error. Okay. So this is what it means, and handling and everything is done on the UI side. So this completes all the four parts, and in the final result, we can see our modern cryptocurrency app, which includes real-time data, infinite scrolling, pull to refresh, and customized price chart. So basically, it's a MVI architecture which we are following here. This architecture is scalable, maintainable, and suitable for real-world Android application. So that's it for today, guys. Thank you for watching. If you find this video helpful, make sure to like and subscribe the channel. In the upcoming videos, we can like add like live session on coding or more thing into the MVI architecture. So thank you for watching. Have a nice day. Bye bye.